Hi guys, it's Thermo-Lover 779 here, and I'm back again with another turbocharged thermo tutorial. In this episode, we are here to answer the age-old question, why do things heat up as they fall from a height? Using our knowledge of the first rule of thermodynamics, we know all energy is conserved in any system, so it is neither created nor destroyed, only transformed from one form to another, and this is always the case.
In this house, we obey the laws of thermodynamics.
Say if I had a weight, and it was dropped from a specific height, all the potential energy at that height will have to be transformed into one form or another, and this happens in two steps. As the weight falls, the potential energy is transformed into the kinetic energy, and then once it hits the ground, all kinetic energy must be transformed into another form of energy. We can assume this is not in the form of work or heat. Therefore, it must be the internal energy of the object, which is a function of temperature. Now let's do the calculation. Our model holds if we make a buttload of assumptions. To start our calculation, we must consider the closed system energy balance. Since we already know of our energy transformations, we can say that the potential energy is equal to the internal energy. Potential energy is found by the mass times the gravity times the change in height. Plugging in our values, we get a value of 392.4 joules. We then substitute this value into our internal energy equation. We use the heat capacity, which was 130, times by the temperature difference, our final temperature minus the air temperature. We then rearrange this to find the final temperature, which was 301.17 Kelvin. This means that there was an increase of 3.02 Kelvin to the object. Now, let's say I'm a hungry student with no working oven. How high would I need to drop an egg from to cook it to my liking? Let's find out. With some simple rearranging of these equations, we can plug in some previously researched eggy numbers, such as the cooking temperature of the egg, which is 328 Kelvin, the heat capacity of the egg, 3000 joules per kilogram per Kelvin, and then plugging in these numbers into the equations, we can solve for the max height needed to drop the egg to cook it by the time it lands on our plate. This was found to be 183.5 kilometers. Thanks for watching, and stay cool like a refrigerator.